all the attendees ultimately. So once again, welcome to all who have joined. Thank you very much for making the time to join us today. In the webinar today, we'll be covering the digitalization of asset management and equipment health through predictive analytics and different other wonderware software provided by AVEVA. The presentation will be led by Rod McKenzie, Paul Myers, and Fayez Fairs from SolutionsPT. Rod is from the Optimal side. For the housekeeping rules, everyone is on mute except for the presenters throughout the presentation. You can be welcome to unmute yourselves once we get to the question and answer session, ultimately post the presentation. And if you have any questions pop up throughout the webinar, please put those in the chat and we'll cover that through the Q&A session. Very much look forward to an interactive end to the webinar ultimately once we get to that stage. So I'll hand over to yourself, Rod, to cover the introductions ultimately. Thank you very much, and everyone enjoy the webinar.
Thanks, Monica. Can we move on to the next slide, please? Okay, there you see the three mugshots of the three of us that Monica mentioned. I'm Rod McKenzie, the Technical Manager at Optimal. I'm responsible for all the technical delivery from Optimal and all the various fronts we go through. So ultimately, what we're going to talk about today falls firmly on my plate. Paul?
Yeah, Paul Myers. So I'm an APM strategic consultant with SolutionsPT, helping businesses get the most out of their assets.
And Fayez Fairs here. I'm APM technical lead at SolutionsPT. Looking forward to really an interactive discussion at the end of the webinar.
Thank you very much, gents. You can see there on the left the objectives of today. So we want to promote the understanding of issues that are causing problems with asset plant health and how to improve data supported decision making. The agenda, an introduction to Optimal from myself, introduction to SolutionsPT from Paul and Fayez. I'll take you through some problems that are facing operators and I'll pose a few questions for you. Then Paul and Fayez will take you through the digital acceleration with artificial intelligence and AVEVA, through a little bit about workforce transformation, empowering safe and efficient operations, a couple of case studies and a Q&A. Thank you, Paul. Optimal Asset Maintenance Solutions were established in 2015 in Aberdeen. Since then, our operations have grown and expanded with a subsidiary established in South Africa in 2018. Optimal is a team of asset management and reliability experts with the domain knowledge of the full asset life cycle. So we are multi-sector experts in the field of asset management with particular focus on complex enterprise asset data management solutions and reliability engineering. We carry out research work with the University of Aberdeen, a collaboration with Swanee University of Technology in South Africa, and have a track record of various asset management optimization projects in the oil and gas, mining and nuclear sectors. This has focused our understanding of asset management efforts and their maturity. At Optimal, we are passionate about providing bespoke, innovative solutions to enable asset owners to maximize value from their assets based on their specific requirements and operating context. Our values of pioneering and excellence are delivered through our team of dedicated experts, which has been proven time and again through our engagement with our clients and partners. Partnerships, as you can see on the screen, are a key element of our business model and provides us with access to cutting-edge yet proven technologies. Monica, sorry, Paul, can you move on? Thank you very much. So our mission at Optimal is enabling physical asset owners to extract maximum value from their assets. And the core values that allow us to do this is pioneering. So we're passionate about bringing innovative technologies and methods to our clients. Excellence, we engage with our clients to ensure that solutions provided by us deliver excellent results and meet exact client needs. And people are our greatest asset. We work together to form partnerships built on trust and commitment. I'll now hand over to Paul and Fayez to tell you a little bit about SolutionsPT and the relationship between Solutions and Optimal.
Good afternoon again, everyone. So yeah, SolutionsPT, we've been around for around 35 years now, and we were founded in the UK. We distribute software products to help customers improve their industrial operations and deliver business value to those operations. We've been the AVEVA Wonderware distributor for over 25 years, and we're partnered with Schneider Electric, who own, as some of you may know, a large part of AVEVA. AVEVA was set up in 1967. They have 4,500 employees. They're a FTSE 100 company, and they have the broadest APM portfolio in the industry, which is recognized and endorsed by ARC, Gartner, Vedantix, IDC, LNS, and others. Optimal are one of 5 AVEVA registered asset performance management SIs in the UK, and Optimal were appointed for their industry knowledge, expertise, and delivery capability that Rod has already explained. Optimal and SolutionsPT have been working together since early last year, and we recognise that the Optimal vision and mission of enabling physical asset owners to extract maximum value from assets aligned very strongly with AVEVA's asset performance management objectives and our own objectives in helping our customers. Optimal's team trained on the AVEVA APM applications, and they've established their APM demonstration and development environments for their customers. Optimal provide the first line APM support to their customers, and they're backed up by SolutionsPT and AVEVA. Rod.
Thanks, Paul. Okay, some challenges that we see operators facing. I'm sure you'll all recognise some of them. You know, data from plant is stored in many systems, and the data needs to be utilised in a structured way. You know, something for you to ponder about. How long does it take to locate machine data for inclusion in RCA? How many systems do you have to interrogate to get the information you're looking for? The current situation we have makes it very difficult to get vendors offshore or onto site for routine service works. So how do you use the operator's walk-around data? How is it put into your CMMS system? Aging plant that's not equipped to send health information to a central point. So how do you assess aged plant without online monitoring of condition or operating parameters? Data in many formats, as I've said, which can cause delays in analysis and allow informed decisions to be made. How do you currently merge all your acquired data for systems and plant health? Have a little think about that. And also in these troubled times we have, perhaps you don't have the staff to collate all the data and perform the analysis. We'll just take you through a quick video from AVEVA that covers some of these aspects, should I say. Paul?
When 82% of asset failure is random, how do you balance risk, cost, and performance of assets for maximum return? How do you make the best decisions to reduce unscheduled downtime, improve operational efficiency, help your people do their best work, and position yourself as a market leader? AVEVA is the only provider that delivers a complete digital thread across your asset's entire life cycle, bridging the gaps between engineering, operations, and maintenance. AVEVA helps you define your asset strategy with a blueprint mapped to your corporate objectives, enabling you to prioritize investments. Now you can combine a digital twin of your plant with built-in powerful analytics to help your teams see information in context, execute data-driven actions, and deliver optimal business outcomes. AVEVA's asset performance management solutions have saved companies millions of dollars in maintenance and spare part costs, reduced unplanned downtime by up to 95%, and saved hundreds of millions of dollars in averted asset failures. For your people, it means a safer, more reliable environment with increased collaboration to focus on innovation. With AI predictive analytics and prescriptive actions, you can predict failures before they occur and close the loop with accurate remediation. With a risk-based asset strategy tied to business objectives, you can prioritize, plan, schedule, and execute safe and compliant work. Empower your people. Break down the silos between engineering, operations, and maintenance to maximize return across your assets' life cycles. AVEVA will take you there.
Good. I hope you all enjoyed that. That's probably the end of the presentation. No, seriously, what we're finding, particularly in this time of COVID, is that our customers are needing to accelerate what they're doing. So we're providing heavy-duty digital acceleration with AVEVA software in the cloud. We're making it fast with rapid time to value, fast deployment, and improved decision making, making it flexible with scalable commercial models, hybrid environments, and lower total cost of ownership. Collaborative, so there's one single version of the truth, transparent collaboration between different teams, as you just saw in the video, and empowering remote working. We make it secure. We have certified data security, high uptime, and reduced dependency on your IT teams. So we're providing the broadest and deepest industrial software portfolio with seamless collaboration and out-of-the-box cloud hub. What we're doing is taking the cloud environment and artificial intelligence and uniting them to enable our customers to make use of the data in their assets, whether they're collecting it from PLCs, SCADA systems, DCS, or ERP systems, taking that big data, abstracting it, visualizing it, and then providing analysis on it, and building a digital twin that is a good model of the environment, and then enabling our connected workers to use that data. The cloud gives us ease of deployment, low total cost of ownership, flexible consumption, and easy collaboration, whilst the artificial intelligence that you'll hear about allows us to do analysis, prediction, provide guidance for operators and engineers, and also to train people. Throughout this APM suite, Asset Performance Management Suite, we have an infused digital thread. So our artificial intelligence is applied to the engineering and operations environment to give a digital twin that can be used by the connected worker. As we're accelerating the adoption of digitalisation, we're operationalising artificial intelligence at scale. So we can now allow people to use search-based navigation. They can build and see their own dashboards. They can integrate with existing ERP systems and other business systems through BI integration. They can see asset condition monitoring on remote assets or local assets and compare values between different sites. They can run OEE analysis, look at the efficiency of the plants, and use artificial intelligence to rapidly analyze the data that is being derived. Our enhanced analytics helps us to reduce downtime and improve efficiency in plants. As we look at failure patterns in assets, only 18% of failure patterns are things that might have been found by reactive or traditional preventive programs, whilst 82% of failures could only be found by applying predictive technology for early warning. If we look on the right-hand side of the screen, and if you think about the way that you maintain your own plants, there are a number of different key ways of applying maintenance. The first is reactive maintenance at the bottom of the screen, allowing assets to run until they fail and then making the repairs. That obviously can be really high cost for downtime for any production plant. Above that, we might have preventive maintenance, where we plan the maintenance based on time or the usage of the equipment against the manufacturer or OEM's schedules. A more intelligent way to carry out this maintenance is to apply condition-based maintenance using rules and logic that have been put in using knowledge from your own team to understand how a particular asset operates. So, for example, if a temperature here is high and a current over here on a motor is also high, then we know that we've got a problem in that motor. We need to schedule some maintenance upon it. Above that, we then have predictive and prescriptive maintenance, where we're using the data in a modeled way to schedule the maintenance on the plant. In APM, in our Insight tool from AVEVA, we provide 4 types of predictive analytics. And here's where the human experience starts to meet artificial intelligence. We have a reactive-based form, condition-based, predictive, prescriptive, and prognostics type maintenance that we can apply. And we do that through automated analytics. Down here, automated analytics, constantly drawing inferences between data on the plant. analysing that data from multiple sources, detecting anomalies, and giving advice to operators and engineers. Above that, we have condition-based maintenance, where the rules are set up for known conditions and workflows. We can also use it to capture operator experience for timely intervention. We can set the responses that we want, forget it until the next time that particular condition occurs. We have guided analytics, where we look at multiple anomalies across the asset, and when we have a repeatable failure pattern that we're able to look out for, we can automatically schedule the response against that particular failure pattern. And then above that, we have advanced analytics, which is a supervised form of artificial intelligence, requiring some training, some cleansing of data, but with some very strong results for our customers. Let's look at those in more detail. So here's where we're uniting the human experience and artificial intelligence. Down at the bottom here, we have the data coming from our plants. We're putting in systems so it visualize, collaborate, and provide business intelligence. And then above that, we have our automated analytics, unsupervised artificial intelligence, our condition-based maintenance using rules, guided analytics using self-service creation of your anomaly detection models, and then advanced or predictive analytics using user cases, which you can help configure. All of these help us to provide prescriptive actions for closed loop remediation for your operators and engineers. So we're connecting the workforce, providing safe environments, helping with reliability, helping with efficiency. Our automated analytics, as we said, is unsupervised artificial intelligence. And what that means is that it sits in the background, learns about the normal conditions in the process, detects anomalies, and posts those anomalies then into what we call our newsfeed area of AVEVA Insight. That means that we can send out messages, we can send out alerts. We can also take into account feedback from users. An engineer or an operator might give a thumbs up to say, yes, this was useful information in what we're doing. And we can detect correlation between two different variables in the plant. Above that, we have condition-based monitoring, very easy to configure. It uses wizards. We define the conditions to trigger our alert. Some examples here might be where a set of conditions happens. We might provide some prescriptive information from our asset library. There's a problem over here in this area. Here's a section from the user manual on how to fix that particular problem. We can send alert notifications via email, create work orders in EAM systems, and send out broadcast messages to ERP and other systems. We can identify the consequences of the failure. There might be safety, there might be environmental, there might be production, and we can send out different alerts tailored to particular audiences as a result. Above that, we have our guided analytics, which gives us anomaly detection by asset. Again, very simple to configure. The user selects which variables from the asset to include in the model. We select a learning period over which the model learns about what's normal in the process. So that then we can create an anomaly score automatically within the guided analytics, which takes three variables, gives the output a score as to how much of a deviation we're seeing, and that then can be used in similar alerting to the earlier form of analytics that we just looked at. So guided analytics gives us a score. It can give us a graph indication of what are the most important contributors to that score. And then once the alert has been shown to the user can be directed to further information about the particular fault. If we send out the anomaly as feed, we can include data so that the operator or the engineer can drill down to trend displays. They can see the values of the different parameters. They can also annotate the charts if they wish. So they might put a message in there, this was during a startup period, ignore this particular anomaly for a couple of hours and put custom information into the charts. Our Insight Advanced Analytics is our predictive analytics component within Insight. It uses continuous improvement based on digital technologies, and really starts from the bottom of the screen here where we have our model, our digital twin that's been created. It's taking plant floor data, multiple sources of data. We're then monitoring that data using digital threads and our algorithms, continually assessing the performance. We can derive alerts from that performance, warning about our performance issues, making recommendations for how to improve that performance. We use machine learning, so we're constantly learning about the data in the digital twin. We can automate investigations into plant incidents and understand what drives the performance of the plant when it's running well. We can empower operators and engineers then to collaborate so that we can consolidate all the learnings together from our model, provide solutions and mitigate the problems and improve the overall performance of the plant. And because it's a continuous improvement system, we will continue improving throughout the life of the assets. The models are more complex than the earlier forms of analysis, but still relatively easy for users and engineers to configure. So in summary, AVEVA Insight allows us to continuously monitor real-time data. We detect anomalies and optimize performance without complexity. And as you can see on the screen here, we've got a mobile phone and a tablet. We can make that data, operational data, accessible to anybody in your workforce that you empower under security, of course, so that they can see data and gain insight to that data anywhere, anytime on the remote devices. Use the search-based navigation, see time series trend analysis, see the process graphics from your plant displays, use geolocation and mapping, so you can locate on particular plants, areas in plants. You can have your own customizable dashboards. We use condition monitoring to provide alerts and notifications, predictive analytics. We can monitor efficiency, provide OEE analysis, and all of this with secure data transport and access. How do we connect to your assets? Perhaps Fires, you'd like to explain a bit more about this diagram that we have here.
Yeah, thanks, Paul. Yeah. So AVEVA Insight adopts what we call a hybrid approach to consolidate your existing process data, which are stored locally, all into one central cloud-based location. So whether that's an HMI, a SCADA system, vibration sensors, or on-premise historian, these are all already in place, and they are collecting and storing much of the process data we are looking for. We can very quickly and securely push that data to the cloud into AVEVA Insight. Authorized users on the right-hand side, as Paul explained, and stakeholders can then easily access and interact with a full set of analytical tools, such as machine learning, condition-based maintenance, guided and advanced analytics, BI gateway, and so on. Next slide, please, Paul. So the sources we can get data from into Insight are variable sources. Data can be collected from, for example, like cloud-enabled AVEVA products, direct connections to PLCs, the cloud-to-cloud integration through REST APIs, or even we can go through a bespoke or custom connectivity to collect that data. Because it's cloud-based, just
sure.
Well, yep. It's cloud-based and offered as a service. There's no requirement for additional on-premise IT infrastructure, which makes that more of like an OpEx cost through a subscription based service in the future. No IT hassle on site. Back to you, Paul.
Thank you, Fires. Sorry I cut you off. Okay, so we've explained how we have our digital twin that we've been helping you to build. Let's talk about how the workforce sees that digital twin. So our digital twin on the left is intended to be the foundation to start to transform the work on which the connected worker solution becomes possible. Our connected worker has a human-first approach to digital transformation. So when we're setting up these systems with Optimal with our customers, we meet with the end users to understand what they need to see, what would they like to have on their systems to help to empower the worker to become an agent of change. Once we put that together, we're finding that we're giving the workers access to information, knowledge and insights, and enabling them to contribute to the health of the asset and the value to the business. We're empowering safe and efficient operations, remote working, team working, collaborative decision making, guided work execution, safety, job satisfaction, and skilled enhancement, all through 5 technologies of industrial Internet of Things, visualization, extended reality, cloud, and artificial intelligence. Let's have a look at a couple of places where this has been used. So Total, using this across 10 of their refineries, they wanted to implement a centralized predictive monitoring solution that would give them an increase in reliability and a reduction in operational expenditure. The solution was to put in AVEVA's predictive asset analytics in a centralized monitoring center so that they had early warning identification and diagnosis of problems across their 10 refineries. They didn't have to make it centralized, but in their case, they particularly wanted to. The result was that they improved reliability and better performance of their critical assets. They had early warning detection and diagnosis of equipment problems, and they had improved maintenance planning and reduced costs. Meanwhile, BASF were looking at their Industry 4.0 initiative. They wanted to build that into all of their plants worldwide. They looked at AVEVA for predictive maintenance and augmented reality, and they also chose the mobility software with integrated workflow for mobile workers and augmented reality. Software was deployed by BASF's internal team, and they were the guys that developed their own models for the predictive monitoring of critical equipment assets. So the job there can be shared between Optimal, for example, and the end user where applicable. The results were that the predictive maintenance reduced the unscheduled downtime, improved asset reliability, availability and performance, and they were able to realize the operators' improvements in reliability because they had more access to the information about the plant and were able to enforce better workflow procedures. I think the fascinating thing for us is that over on the right-hand side here, they've already rolled out the augmented reality and the predictive analytics to over 400 plants worldwide. So a really big standardization there. Okay, Rod, back to you, sir.
Thanks, Paul. That kind of finishes the presentation. Just a little bit of housework for us. All those who are here, we'll email you a link to the presentation so you can review it again at your leisure. If there's any non-registered participants, just drop me an email. My email address is at the bottom there, and I'll send you a link for it. Information is also available on our website at www.optimal.world and will be shared in the post-webinar mailer. We have data sheets on AVEVA, Insight Trial download where you can actually go and play with the system, and other Optimal activity. Other case studies and infographics are available, so just email myself and they can be discussed and shared. So have we got any questions, folks?
Thank you very much to Paul in the first instance, Rod and Fayez for delivering the presentation. I hope everyone's enjoyed that. So far we got one of the questions. Once again, we're not a massive group, so if you want to just ask a question, you can unmute yourself and put that forward to the team. But the question that has been put forward comes from Etienne, and that's, can you or do you use data from other similar plans to improve the data sample sizes for the AI models?
The short answer to that is yes. One of the things that we can do is upload historical data. So what you can do, first of all, is tell the artificial intelligence to learn from this point forward. And within a couple of weeks, you'll have built up some good, healthy information about normal operation. But we can also upload a text file of historical data, and in theory, yes, you can do it from other similar plants to train the system on what is normal operation. So yes, you can make use of historical data from other plant.
Okay, thank you very much for that, Paul. Etienne, does that answer the question for you, or would you like to ask anything in addition to that?
No, I'm happy with that. Thanks.
Thank you very much. We do have Salem typing. So whilst we're, oh, there we go. So what about new plants with little to no historical data? And would you base the data sample on for that?
Yeah, if you've got little or no data, you really are going to be starting almost from square one. But one of the good things about AVEVA's APM suite and the way the models are configured is how quickly they start to learn the process, and how they then continuously improve their modeling of the process. So the sort of 2-week time frame that we talk about to get the initial learning done is actually quite short by industry standards. So yeah, appreciate you be starting from nearly a position of no data, but within a couple of weeks you should be up and running. And what we're finding, Fires, for example, is working on projects at the moment where the data can be started, the learning can be started before you've fully gone live with the system. So as you're finishing off some of your final configuration, you can be having the system learning and listening to the process and learning normal conditions effectively before you've really gone live with the system. In fact, it might be worth us just talking, Rod, about the typical kind of project with it.
Yeah, absolutely, Paul. Thank you for that.
Yeah, have a look. So typically the steps in getting into a project like this would be, as you can see there on the left there, we've got a briefing. We would have a combined team effectively here, so Optimal, SolutionsPT and the customer, educating the stakeholder team that would be involved about what would be possible with this kind of system. Having the stakeholders input then about the business so that we understood the best assets to be looking at within the business to deliver the maximum value back to the business out of this kind of approach. And then we look together at an opportunity assessment where, as it says on the screen there, we look at the specific areas to improve. What sort of implementation process might we have? What sort of order to do things in? The economical potential of each stage around each asset or each area of the plant, because we want to deliver the biggest improvement we possibly can as early as we can. So we always stage these things. And then having established from that opportunity assessment, what are the key areas to look at for the business, we would then get into a production pilot where we're taking one of those key areas that we talked about, 1 or 2 assets in that key area, doing a pilot and demonstrating the return on investment value to the business, and then starting the rollout to the rest of the plant. And as you can see here, we can get to a rollout with customers within 4 to 8 weeks of starting the whole of the process. So it is quite quick compared to other technologies to get a return on investment.
Thank you very much for that, Paul. There's another question in from Mike. So when starting from square one, how do you judge if that 2 weeks learning period is complete and representative, and does this vary in different industry sectors ultimately?
Yeah, that's a very good question.
Yeah, if I can, Paul, just
please,
reflect on that one. So when you define square one, whether it's a new machine, new asset, you don't have historical data, or a new system in, for example, AVEVA Insight. If it's an existing asset with some historical data, as Paul mentioned, we can utilize both historical details to learn, to retrospectively get the system to learn from that. If it's quite a new piece of assets and you are starting to collect those details, the 2 weeks are not a fixed period. This is like an initial period for the system, for the machine learning bit, which can automatically start making enough trends to reflect what's normal, what's not normal. It will be suggested. You can reflect on that and vote to say that's useful or not. As you start using the system beyond that 2 weeks, you can start configuring your guided analytics, your advanced analytics, and you can pick the training data period as best to reflect your normal condition. Hopefully that.
Yeah. Yes, so by looking at the trends, you can see for yourself, you'd be able to say, right, that's a normal period of activity. I'll tell the system that's the normal period and not to learn from the abnormal period.
Thanks very much for that clarification, Paul. There's a couple more questions coming in. So, question from John: would this system replace something like a Bentley Nevada System 1, or would it sit on top of it?
That's a really good question. So AVEVA's APM portfolio is designed to enhance and complement systems that are already in place, and the Bentley Nevada systems certainly do a very good job already. There'd be no reason to, in most customers, there'd be no reason to look to replace them. So yes, we'll be able to take input from the Bentley Nevada system into the things like the anomaly detection, the guided analytics. So we start to look at particular variations in vibration and that sort of thing, using the inputs from the Bentley Nevada system itself.
Thank you very much for that. John, does that answer your question? Please feel free to unmute yourself if you'd like to come in.
Not quite. I guess we're a new plant, so we don't have System 1 or anything deployed at the moment. We're going into a Schneider DCS, which will take the raw data inputs. And I'm looking at what do I need to sit on top of that to give me my kind of predictive analytics. And, so rather than implement System 1, can you just avoid implementing something like that and go straight to this type of system? Or if you did that, that mean you lost out on your waveform analysis, your spectrum analysis, etc.?
Yeah, I think we probably need to sit down and look at how much you might be losing. Could you get around it? Are there other parameters that you're already passing to the DCS that we'd be able to take as a good indication that you had a problem? We've been working with customers recently where we've, somebody said, yeah, we'd really like to have vibration analysis on this pump. Well, okay. Are you already doing some mobile operator rounds? There is somebody walking by it. Yes. Well, you could just say to them, have a listen out, and does that machine sound abnormally loud from the way it normally sounds? And they've been able to include that operator input into the conditions and then the anomaly detection. So without having vibration analysis on the machine, we've used the human ear there to say, yeah, there's a likely problem with that machine. Let's get on and do something with it. So that would need to be checked out, really, and a discussion around what are you really looking to get out of it? What sort of assets are they? Could we get away without having System 1 in there at all? Yeah.
Okay, thanks.
Thank you, John, for the question, and thank you, Paul. We have another couple of questions. So another question from Salem: is there continuous validation of deployed operational profiles?
I'm not sure.
Like automatic validation, or more like a process of profile designers and
Salem's saying automatic. Salem, also you can unmute yourself. As I say, we're not a huge audience, so it's absolutely fine if you just want to come in.
So basically, following up on the new plant, so the model.
Sorry, Salem. Okay, your audio quality is really poor, so we can't really actually hear you. But we'll go on the basis, Fayaz, that Salem's saying it's automatic.
Hello, is this better?
much better.
Yeah,
Yes.
we can hear you much better.
All right. obviously, as with more historical data, the model would predict, will be trained better. So is there a way to update these models as you get more historical data automatically, or you'd have to go back manually and train the data?
Yeah, there is a best practice process for you to revisit and update your operational models that you have already deployed. If you think that you have obtained a more appropriate data which reflects your normal conditions, or when you have some sort of like alteration or changes to your system, something has been added to the process, which makes your initial model needs revisiting and so on. Automatic update, that's, as I said, that's a process where a system matter expert needs to go and decide what is appropriate data over which period of time I can consider my normal conditions, and you can retrain a deployed system to learn from that data. Assuming that the more history you have better sample. Could be sometimes questionable. Sometimes it might not be correct. The most recent data might be based on deviations already being built up. So assuming that is representative of your normal conditions, if you automate that, in some cases you might not be 100% correct. Technically speaking, there isn't a way of automatically saying the more historical data include into the training, but there is a really, really easy, quick best practice method within the applications to update your training data set.
Thank you very much for that, Fayez. We do have another question in from Anu here. So how do you determine the best fit artificial intelligence model in AVEVA?
Maybe Paul, through if you want to go through the assessment and optimization, possibly, just part of our portfolio.
That's right. So we've talked briefly about the asset performance management assessment that we can do with Optimal and yourselves. There's also an asset strategy optimization piece of work that we do together with the system integrator for customers. The asset strategy optimization looks at the whole of the customer's business, how they're using their assets, what their business strategy is for those assets, and really gets into the nuts and bolts of how maintenance is carried out. That can help us to identify the best AI application to use. The second thing is that the APM assessment, as we're measuring the asset performance management that you already have in place and your interests for the future for the business, that APM assessment can help us be guided very quickly to what sort of analytics will suit your process and application. The way that the products are licensed, or the elements of the products are licensed, they're on a subscription scheme under something called flexible credits. The customer takes a particular value of credits that we've worked out jointly would be appropriate for their business. And then under those credits, they can try out different elements of the products. So you don't have to say at day one, right, I definitely want just this component here. What you can do is say it's likely that we're going to use this component, but for the pilot project, why don't we use this component, but also turn on this part of the portfolio as well. So we might use the automated analytics and the guided analytics in the pilot, but they come back later on and say, actually, we just needed the automated analytics together with the condition-based maintenance.
Thank you for that, Paul.
Choices. Yeah.
There's a comment there from Roy as well. It should come from the asset management strategy directly linked to the business plan. I'm not necessarily sure which part that applied to. So Roy, you mind just coming in?
Yeah, guys, it just kind of follows on exactly from what Paul was just talking about. You know, the product has got to be directly linked to the business plan and appetite for risk and amount of cash available to invest. You know, some companies will just want a Ford Escort and the next one will want a Rolls Royce. So I guess it's always it's a problem that I've seen quite regularly with service vendors, you know, solution providers like the Optimal, not you guys, but people like you. They've got a fantastic product and the pitch is absolutely amazing. And this thing is going to stir the mince and make the toast for me. But actually all I'm needing is something that's, you know, like very, very basic vibration analysis, for example, and trending off of that. So it sounds like it's a great collaboration that you guys have got and pulled together, and I'm sure it'll be very successful. I guess we just need to be very wary that it's definitely not one size fits all for all the different assets that you might come across.
That's absolutely correct. Yeah.
And that's why I put the comment up there, and I think there's maybe a few guys online that are pretty new to asset management. And one of the biggest messages I've tried to get across as vice chair of the Energy Institute is that the asset management strategy seems to be this other technical thing that sits way off to the side of the business plan, and a lot of companies and assets fail because they don't link them. The asset management strategy is should be directly linked to the business plan, which should then lead into products like we're talking about today. To make that decision and actually deliver the business plan, make more money quickly, or make less money but make it over a longer period of time. Well, that's very different when you start looking at asset management strategies and the products like your one.
Yeah, that's a really good observation. I don't know if you remember on the video, there was a bit about under-maintained and over-maintained.
Yeah.
And what we've found in the marketplace is that I'm not sure whether it's a particularly UK thing, but very many of our customers have a break-fix maintenance strategy going and a very small planned and preventive maintenance strategy above that. And that's as far as they go. And when you talk to them about what their downtime is, you know, they'll say, oh, we're suffering, we might have a 60-70% uptime. You say, well, how does your business live with that? Well, I never thought about it. You know, well, that could be £1 million a day or more, depending on the industry you're in. You know, enough to fund the entire maintenance department every week, just with downtime that is preventable. So yeah, as you say, linking it to the business strategy, and even the very simplest condition-based maintenance, when we turn that on in Insight, just having a look, we've got a company we were talking to about making jam. They got a valve matrix of 200 valves routing jam product from kettles into jars at the other end. And the biggest downtime problem in the site was these valves gumming up with jam. So if you put condition management on, looking at the travel time of each valve, end to end, full stroke, I just had that sitting in the background. It would give you a list each day of which valves were starting to get sticky that you could just go around and just clean up. And yeah, a miraculous change to the business straight away. You know, you weren't taking down your whole jam plant just because you got a few sticky valves going on. Yeah,
absolutely. Yeah,
sounds like a sweet solution, Paul.
Yeah.
Boom.
Don't get me started on
There's
jam.
so many examples of that, as you guys will be well aware. There's so many examples of that lack of kind of. It's weird. It's like big picture thinking, end-to-end process thinking. But normally, the solutions that give the biggest impact are little tweaks and little minor changes.
Yeah.
Interesting. Anyway, I digress.
No, thank you very much for that, Roy. Rod, I think you were trying to come in as well into the discussion.
No, it was covered what I was about to say. Well done, guys. It's you know, you don't have to have the Rolls Royce. You can have the Ford Escort. At the end of the day, it's what fits you. It's when we go back to the timeline and look at it. You know, we talk and discuss what it is you want. We're not going to come in here with a big box of tricks and say this is what you need. We need to work out together exactly what it is you want, what you need to help you move forward, and we will design what we can do to help you to achieve that.
Absolutely. Thank you very much for that, Rod. Any other questions from those attending? We are coming up to the hour, so we'll be finishing up. But if there is anything else that you wish to ask at this moment in time while the guys are still on, absolutely welcome. If not, as you would have seen in the previous slide as well, we have the contact details, and obviously you can get in touch with either of us, and we'll set up a conversation and have a discussion to understand further as to what your specific requirements are. Thank you very much for that, Paul. But yeah, thank you once again to all who have asked questions and interacted, and thank you to the presenters, Rod, Paul, and Fayez, for providing insightful and comprehensive answers as well. The presentation was a big brief over the whole system, but specific discussions can be had ultimately on the back of that. So yeah, anyone would like to come in before we close up? Okay, well, if there's nothing else to add from the team, I'd like to thank everyone once again. It's been a pleasure having you here, and we will share the recording accordingly in post-webinar communications. Wishing you all a lovely afternoon, and we'll stop the recording and complete the webinar. Thank you.
Thank you, Monica.
Thanks very much, everybody.
Thank
Thanks
you all.
all. Bye.